welcome to the last lecture, in quotation marks. As you've seen, my lectures are kind of involving some work of yourself, and true to all the other lectures, that's how we will actually start. But today we will talk about Internet of Things maintenance, or predictive maintenance, do a little bit on heartbeat monitoring, and then I will, so these two parts you will work, then I will work a little bit and show you some tricks how you can access your gateways from outside and can network gateways together. And if we still have time, we will look at some Internet of Things success stories today, and then we will be done. I got a lot of thanks from my guests yesterday, so they enjoyed talking to you, and they wanted to express again, if you have interest to go to Brazil, feel free to contact them. So, Internet of Things maintenance. And so there's one important topic we haven't covered at the moment, and Internet of Things is often used in the area of predictive maintenance. So I will not tell you what this is, because this is very easy to find. So Google predictive maintenance. Try to figure out what problems does it actually solve. How is it related to Internet of Things? So why are we talking about this? And then find 3 examples. Examples is important. 3 examples of predictive maintenance in the Internet of Things. And which role does data, big data, play there? And then we discuss with neighbor first and take it open. So, predictive maintenance. Hey, let's take it open. Let's quickly go through some examples together. I've heard a couple of nice ones here. Can you repeat for all? You had something in the corner street, didn't you?
Yeah, Volvo developed a solution tracking the spelling and of the rotating equipment, clearing and motor effects, so you can detect when the car needs maintenance.
Okay, good. So you guys had some nice examples, if I remember.
Yeah, infrared thermography for electrical components.
I thought that was actually very interesting. So what kind of electrical components were mentioned there? You showed it to me.
Like electric panels or...
Electric panels and? Kind of some devices which mixed oil or so, or which were immersed in oil. I thought you showed me. Did you find one?
Yes, like for a paper factory.
For the conveyor belt in a paper factory, yeah?
You use this because it's rotating and all, you can use a sensor if it's rotating.
Okay. You guys, I haven't asked you before. What did you find? Other examples?
I found examples in constructions. So they use the predictive maintenance like monitor the machinery.
Of what company, or who monitors it? Construction company.
To monitor the state of their machinery, like bulldozers, lifts, loaders, and so on. So they attach sensors to it. For example, temperature or tire pressure, fuel consumption, and then they fulfill.
So I think we had a lot of kind of car and machines. You guys had some cars too, if I remember. General Motors, and you found something for airplanes. Okay, what else do we have? You found nice things too here.
Yeah, for example, Maastricht is a
Paper factory? What's it similar to what?
Railway. There's something with the railway to check the rolling and stock, as in the other
The motors or the engines?
The rails.
Oh, the rails. The rails, yeah. This is quite small railway. Okay, Okay. You had a nice one here, if I remember correctly.
For wind parks.
Yeah. Yeah. So that was kind of when I did the exercise last time. That was the one everybody found out for some reason, and that was the first one. So wind parks and the turbines and kind of measuring how much it vibrates. In general, I think you said also, but you said actually, what is kind of in general where you want to do predictive maintenance?
Something is like far away or accessible.
So things that are hard access or not easy to get to, yeah. So why did we need data analytics here? we were already thinking about that one.
The problem is there's so much data and you can't just work over the huge payloads sequentially, so you use some kind of big data techniques to mine special features or patterns and use them to
filter, to figure out and to detect spikes, and some of you have actually worked with the heart sensor, and you can see that's already a lot of data. You want to just get the ones where it where actually your heart is beating and something like that, and then you might actually, that might be the normal case, and you want to find the anomalies from it. So there you need filter techniques. You have to probably look at frequencies, maybe do a Fourier transformation, or actually use machine learning to see if you can spot anomalies in there. So that's actually really big and really profitable application space of the Internet of Things, which is strong focus on big data. And I think, if I remember correctly, in the mining example, the guy yesterday, Alexandre, was actually saying, yeah, that's the only thing where they actually hired a whole company for their company in the Internet of Things space. They had, I think, this visual monitoring of their areas, and so that was even taking drones and visual recognition into the equation to help the company work better and have this element of maintaining and being able to react to disturbances quicker than letting some disaster coming up. So what else are the connections to Internet of Things? Why are we talking about that? Have you read connections about predictive maintenance and Internet of Things? No? Just big data?
Yeah, I found out that IoT is basically the network used to transfer the data from the special use case to a certain point where it's gonna be processed.
Yeah, so the connectivity, how do you actually get the data from somewhere? How do you kind of collect from lots of sensors data? And so that, as we said, one of the big things is not only data and Internet of Things, also connectivity, and providing the connectivity, providing the ability to measure at all what can give you a hint about what could go wrong is Internet of Things. Let's see how the timing works out. Let's do this just for 5 minutes here, yeah? So, I don't know if anybody of you stumbled about the heartbeat stuff while reading on predictive maintenance. Anybody saw that mentioned? If not, look it up now. Just 5 minutes. How does heartbeat monitoring work? Or how does a heartbeat monitor work? And what can it be used for? And then we will discuss together how this could actually fit into this equation of predictive maintenance. Yeah? Is this, and then think actually you have seen the heartbeat monitoring already in ulno IoT. So what is it there, and could you use that in some regards to do predictive maintenance? Just 5 minutes, yeah? Just Google heartbeats monitoring. Get an idea what it is. And then reflect it back on predictive maintenance. Let's take this open. If anybody found a good definition, I know at least one person who did. Reinhard, sharing with us?
Heartbeat is a signal that is generated at regular intervals to indicate that something is working correctly.
So a signal which is generated at regular intervals to show that something is working correctly. I like that one. You've seen any examples where?
An example is like the nodes, like 3 nodes, and they are connected, and every 3 seconds node A sends a message to B, and B to C, and C to A, and there's an acknowledgement message, and if a node misses the heartbeat where all messages are sent 4 times, then it sends a failure message. Like
So the other 2 nodes can then detect that one node is not working correctly. Yeah. So that is, and it's. Where did you find it? In which context? This example, networks or?
Yes, networks.
Okay. Yeah. So you can use it to monitoring the functioning of a network. Any other examples where you found heartbeat monitoring? Yeah.
It's not so much in a network, but pacemakers also use this.
Which are very close to actually heartbeats, yeah.
It's called the watchdog timer.
Watchdog timer, very good. And so it's not only in pacemakers. So nearly every operating system has watchdogs in there. So that's watchdog is a really good term, which is often used synonymously to heartbeat generators. Yeah. So if you Google for watchdog, you find a lot of similar contacts. So where we have seen that? Yes, in ulno.net, but what is using what ulno.net is actually using to do something related here?
Keep alive.
Yes, it's basically every 5 seconds or so it sends the status of all the devices it knows. And the intention of this is actually to have some kind of very simple heartbeat mechanisms in there. So how could we use that for doing some kind of predictive maintenance? Actually, you were very close with your network example. So you try to apply that, what you just did, and look if we could use that to monitor our Internet of Things network here. Any idea?
I mean, it's not really predictive, but if you monitor every node and see that once one failed, then you know that you need to do some maintenance there.
Exactly. So it's maybe not predictive, or maybe you can just see, okay, if one thing fails, there probably others will fail too, then it becomes predictive. But it's kind of a first step to doing maintenance and doing predictive maintenance. What would we need to do to really do predictive maintenance? For example, let's take the wind park example. So
Some analysis.
you have any sensors you might put into some windmills to do predictive maintenance with Internet of Things. I mean, if the heartbeat stops, we definitely know that we have to get out there. Yeah. Okay. First thing, we want to actually get data all the time, so we know that this thing is still working. Anything else we could install?
Yeah. In wind parks, you could use weather forecasts.
Okay.
So
Yeah.
if there's no wind predicted, then you can maintain the machines.
Ah, that's good. Then you know that you can maintain. But so what they usually do is kind of install something which kind of measures how much vibrations are in the windmills, and then you can actually, with machine learning, figure out if the vibration gets in a kind of weird pattern. You know that the windmill is actually failing, and based on this, you can then start the maintenance. Then you have to look at the weather forecast when you can actually change the machine. Yeah, very good. So, something by me, which might come in handy for the work you are doing now. Who has heard of port forwarding before? Okay, so do you guys know what that is? How to really make use of it? So imagine you guys have now the big teams, but you have only one gateway of your Raspberry Pi, and you still want to be able that several people work on Node-RED on this one Raspberry Pi. So you want to be able to get the port of the web interface somewhere else. On which port is all the stuff on the prepared Raspberry Pi gateway running you have from me? That is the first guess, but it's wrong. Because if you see, port 80 just forwards to which port? No, it's actually going to port 443, which is HTTPS. Yeah, so careful. Most of the web services today are not running on port 80, but on port 443. So, have you heard of dynamic DNS? Where do you use it? What is that?
Yeah, if you have no static IP address, if the router reconnects, it gets from the provider a new IP address, and the dynamic DNS service generates a name for you, and you can access and stores the changed IP over the time with a small environment.
With a small time to live.
Thank you. And you can access to your home gateway router over this specific name.
Yeah, so you get a dynamic name. Yeah, so it's actually a service which allows you to give you one specific name and then a dynamic IP address which changes behind it. So I've done something. So I put my Raspberry Pi gateway in the Rapheim, and I thought, oh great, we can access this from here today. So I gave it. So let's check this script here I wrote. And so I gave it this ulno IoT gateway at SPDNS. So SPDNS is a service, a free service where you can actually get a name. So if we look at that, let me log in there, then you see that I have a couple of names there. Doesn't know it anymore. Sorry.
You can right click on key pass.
SPDN, okay. No, it was a different website. So you see I have basically two names here. Yeah, so that's my home router, and that's this gateway I have. And so great, I said, so I can now actually go to ulno IoT gateway. So let's execute the script and go there. And it doesn't work. Why? So actually you had to make sure that it's the right IP address, but I still can't connect to it. So it's a nice solution, lots of routers support that. So it was the go-to solution for actually making your own gateways and routers accessible. But, No, that's also the port I forwarded. Well, good idea. So yeah, even if I ping this, if I do, let's make it a little bigger. So even if I ping this ulno IoT gateway, SPDNS, DE, see it sends and you see this this address here is actually it's a Rapheim, yeah, so it's where I live at the moment, but I can't get in there, so kind of annoying. Firewall, yeah, so Rapheim is heavily firewalled nowadays, and so lots of internet providers are also heavily firewalled nowadays. So this was a nice solution until basically the connections in stopped being allowed. It has something to do with, yeah, I don't know, 30% of Windows computer being hacked, and so not exposing them even further to kind of attacks from the outside. So Internet of Things providers have actually, Internet providers have actually locked down quite some services, so you can't do that anymore. Okay, what is left? So we can actually do something with port forwarding now, which moves us around. So if you can use dynamic DNS, then this is the easiest solution. So now we are at the point where we can't use that. So I have a topic here which is called port reflection. Anybody knows what port reflection? Sometimes it's also called a jump host. What is that? It's kind of, I'll show you now how do you hack out of a firewall. I don't know if this is actually good. So if you have a host, if you have one computer in the internet, you can access from outside, which is not behind a firewall. You can actually tunnel yourself out of the one network and then connect from there. So I will show you this. So I own ulno.net. So we will log into my ulno.net account, and there I have forwarded the SSH port of my gateway in the Rapheim onto port 5555. So if I go now there, I can use IoT Empire, and you see I'm in my gateway in the Rapheim. And there you can see, yes, I have a software running, grep, DD client. So DD client is this dynamic DNS client, which is actually updating the IP address, and this is how we get the IP address, but we can't go out. But you see the SSH port is open, so it wasn't a port problem. So, but now I want to actually access the Node-RED which runs there. So I want to do some more port forwarding trick. Let's actually check first what I do to get this port out to the server, to make this reflection port. You see here I am basically using this option. See that? So it's the -R option for SSH, which allows me to transport one port out into the internet. Yeah, so this means if I use this option, I can send the local port 22 of my local network to port 5555 on my server. Yeah, so this is actually logging into ulno.net, and I have a user port forward helper on there. And so this transports my port to port 555, and this is what I use now. Now this is, so I logged into my server via this jump host in between. So, but now I want to actually get via that server the port 443 into my computer. So I basically have to go to ulno.net, and now I have to transport the SSH ports to my local computer, and then I can use that SSH port to transport the port of Node-RED to my local computer. So let's do that. So basically let's mirror the 555 port to my local computer. So that should be done now. We can test now again if I go locally to and this is ulno IoT localhost. So now I have on my localhost my server from the Rapheim. So I've built 2 tunnels, and then I can build another tunnel. So I can use this connection to build the tunnel to let's say 4443 localhost to 443 on the host I'm actually logging into. So this connection should be up. And now let's see what we have on, oh, this actually, localhost, so 44443, and it's HTTPS. See, and we get this thing here, an exception. And see, there we are. We're now in the Rapheim. Easy, isn't it? Just 3 tunnels and we made our way through. So if you can set up anything which is SSH accessible somewhere, you can use this as a jump host to make other computers accessible to you. So we're drilling a lot of holes through firewalls here. I thought that's kind of neat. So you might be able to make use of that in your final project. And basically I did the reverse thing when I showed you the owl, remember? So the owl is kind of the same concept. It just has a couple of less tunnels, but this way you can actually tunnel 2 MQTT connections together. So MQTT is running on port 1883, and so let's check out what I did here. Here with MQTT. See, I go to my server, and then I tunnel the port 1883. Port 1883 to local port 1884. So I have then basically 2 MQTT servers accessible on my local computer, the one I run locally and the one I've tunneled in. Yeah, so with this way I can also tunnel MQTT around. So basically if I want to have the MQTT server from this gateway here, I don't need this port 4443. So let's check this again. So if we stop this connection, we can, come on. So we can actually add here another tunnel and can, for example, say 1883 localhost 1883. And now I have actually my MQTT server also here on my localhost. Yeah, that was kind of a small detour here. And yeah, I think we can still make the last small exercise. So for the rest of the class, I wanna, now first I have to say what's coming in lab 12, continue working on project 3. And I want you today to start the lab with a kind of little stand-up Scrum meeting. Yeah, what is, so some of you might know that, but I want you actually to start the lab later in kind of electing a supervisor for this small thing, which is called the Scrum Master. Yeah, so your team leader or some person who is good in controlling and organizing things. And it should be just 10 minutes. Yeah, so just start with a 10-minute stand-up. And a stand-up meeting means everybody stands up. Yeah, and so everybody has then to tell what they're currently doing and what they want to do next. And if they are stuck somewhere. And you should write a small log. So somebody should actually not stand up and sit down and say, okay, what are the problems, who is doing what, so that we know that the team is actually functioning. And then basically, last task you have done, next task you will do. Anything stopping you from being productive. And then the next thing you should do after the stand-up, sit down together and write down all the tasks you still have to do for your project, and then assign the tasks. But I think I want you to experience, one, the idea of a stand-up where everybody reports what they're currently doing and what is stopping them from what they are doing. And if you want, you can continue that on your next meetings. So, but in the rest of the class, I want you to look at least at some of the success stories. As we don't have too much time left, maybe just focus on the first 3, Runtastic, Loxone, and Numea, which are basically all Austrian companies. in the Internet of Things sphere. Think about why I picked them. Why do they have something to do with Internet of Things? Google their history, where they're coming from. I think most of you know the Runtastic story. And yeah, are they successful in the Internet of Things space? Why or why not? Then we'll quickly discuss and finish the lecture and head to the stand-up. Oh yeah, look which one you like best. Okay, unfortunately I forgot to record the last part of the lecture. It was only a couple of minutes, so I didn't have much time. I didn't miss much time here. Anyway, so we just discussed a little bit the three companies I wanted them to study, Runtastic, Luxona, and Numea. Both Runtastic and Luxona kind of a little bit predate the time of Internet of Things. Runtastic is a fitness company, but I think it's still worth mentioning here, and it's one of the success stories we like to share at the university. I do currently this talk for at the University of Upper Austria in Linz, Austria. Luxona is the company I mentioned very often in my home automation lecture, and they sell a key product which is their home gateway, and it connects to basically nearly all home automation technologies that are out there, and this is kind of quite a great feat to get a product which is so versatile. And Numea is a recent discovery. It's more like a B2B Internet of Things company selling frameworks. It's a little bit comparable to ulno.net, but of course more in an industrial sense, and also they support a lot of end devices, but they're focused more on the framework part in there. Yeah, that was actually my lecture, and I send now the students to the lab. I hope the international viewers enjoyed this lecture part. Please leave some comments in some of the lectures, and if you enjoyed it, I would like to hear your critique or see you in the ulno.net chat group. And I hope we can take it a step further, and maybe I see some of you later in my home and building automation class or some other maker class. So I'm looking forward to see you again. Stay tuned and let's see what will come next.